Okay, so with this little practice one, we're saying a 100 kilogram cart goes around the inside of a vertical loop of a roller coaster. The radius of the loop is 3 meters and the cart moves at a speed of 6 meters per second at the top. The force exerted by the track on the cart at the top of the loop is something. So again, try this one out, pause it really briefly, and then check your answer in the rest of the video. Okay, so hopefully you had enough time to pause it and give it a quick go. So with this one, we're looking at a lot of the same situation that's been popping up, where we're looking at stuff at the top of a circle. So we're saying, okay, here's the top of our circle. I think the reason that a lot of these problems are dealing with the top of the circle is because conceptually it's really weird. It's weird to think about gravity acting as a centripetal force. It's weird to think about the normal force making something move in a circle, especially at the top. So it's all very weird. But so again, we're looking at the top. We're saying, okay, I can circle my object. Looks like I have a contact force, kind of missed, that's okay. Contact force between the surface and my object. So yeah, if we're looking at drawing this force diagram, I can say, well, here's the center of my circle. I have, if I'm looking at it, I have a normal force between the surface and my object. I know that normal forces act perpendicular to the surface, which means that my normal force is going to be pointing downwards. And then, of course, I have the gravitational force because this thing is a massive object that exists on Earth. Massive being it has mass. So yeah, I have this situation. And now what I can do is write out and say, well, both of these are pointing inwards towards the middle of my circle. So both of these are working together to be positive centripetal forces. So I have positive normal force plus positive gravitational force is equal to mv squared over r is equal to my mass times acceleration. Let's really quickly write F net. So F net equals Fn plus Fg. Both of these are acting as positive centripetal forces. So now we can come in here and start to kind of plug in some numbers. So I want to figure out the normal force, the force exerted by the track on the cart. So yeah, I can do that. So I can say Fn plus my Fg. I know my equation for that is good old mass times g. So I have 100 for my mass. I'm just going to call my g 10 and make it a little bit easier on myself. Equals a mass of 1,000. Or sorry, 100. V is going to be 6. I have to make sure I square it. And then R is going to be 3 meters. So I can say Fn is equal to 100. I'm writing at this angle and it's kind of difficult. 6 squared divided by 3 minus. All right, and I can plug this into my calculator, and I end up with, oh gosh, where's my calculator? Woo. All right, I found my calculator. It was literally right here. I just kind of overlooked it. That's okay. So I end up with a normal force of 200 newtons.